Welcome back, still I hope you are doing well. So last time we saw basically the integral. It was question 5. We saw the integral of 32 and 60 minus x to the fourth. We saw how to integrate it, and this simplified into finding these integrals. You understand? This is basically the integrals. These two are basically like integrating 1 all over ax plus b dx, and this was basically an integral of the form a plus bx squared, where the substitution would be tan of all what is inside square. Okay, now we shall finish with this exercise, and I'll give you hints. I'm sure you've tried this already. I'll give you hints on how to go about and tackle these integrals. So let's go directly to this exercise. So let me go to the next page. A minute. Okay, the integral of this. Don't be afraid of this integral. This is a very simple integral. The first thing I will do here is I will develop what is on top. When I will develop this, I will clearly see that the power of x on top will be greater than the power of what is below. So I will proceed to a division. So let me first recall that when you are to develop a plus b all that square, it is the same as a squared plus b squared plus 2ab. If you are to develop a minus b squared, this will be a squared plus b squared minus 2ab. That's just a recall. So this will be equals to what? My a here, this is identical to this. So my a here is x squared and my b here is what? 1. So this will be equals to what? I'll write my dx here. This will be equals to x squared, all that square. We are applying this formula. Plus our b is what? 1. 1 squared minus 2 into what? Our a is x squared into 1 all over x cubed. I hope that's okay. So this will be equals to the integral of, here I will have x to the fourth, because a to the n, all that to the n is equals to a to the nn. So that's just a reminder. So I'll have x to the fourth plus I'll first write this minus 2x squared plus 1 all over x cubed dx. Okay, now instead of writing my long division sign and doing the division, I can directly divide here, because this is not this x cubed. There's only this x cubed that we'll have to divide through with. If I was having plus an x or plus something behind, I will necessarily draw my long division sign and do the division as we used to do. So here I will simply write this as the integral of x to the fourth all over what? X cubed, because if you have a plus b plus d all over c, it is the same thing as a on c plus b on c plus d on c. Let's say this is minus to show that it also works with minus. You understand? So I'll just apply this. So I will have the integral of x cubed all over x to the fourth over x cubed dx minus 2 integral of what? X squared all over x to the third dx plus integral of 1 all over x cubed dx. So this will be equals to what? I will have here integral of x dx minus 2. This is x squared on x cubed, so I will have integral of 1 all over x dx plus what? Integral of x raised to the what? Minus 3 dx. So these are very simple integrals to do. The integral of x dx will simply equals to x squared all over what? 2. Because we are using what? The integral. We know that the integral of x to the n dx, where n is different from minus 1, is simply equals to x to the n plus 1 all over n plus 1 plus a constant of integration. So I'll have here x squared plus 2. Here I'll have 2. The integral of 1 on x is simply ln of the absolute value of x plus the integral of this, I'll have x to the minus 3 plus 1 all over minus 3 plus 1 plus the constant of integration. So this implies the integral of x square minus 1, all that square, all over x to the third dx will be equals to what? X squared on 2 minus ln of the absolute value of x. This will give minus 2. This gives minus 2. So I will have, since there is minus 2, I will have minus 1 on the 2. This will give x to the minus 2. So x to the minus 2 will be equal to 1 on x squared. So all over x squared plus our constant of integration. Our k belongs to R. K belonging to a set of real numbers. So this is the integral. You see that it's a very simple integral. There's nothing complicated in it. Very simple. So let me just give you hints on how you will go about with the others. This one, when you look at this integral, what do you notice? You notice that if you differentiate this bottom, what are you going to have? 3x squared. So you're already having part of this 3x squared on top. So naturally, what do? You multiply top and bottom by 3. This integral top and bottom by 3, you understand? And because you know that d of what? 1 plus x cubed is equals to what? If I differentiate this implicitly, I will have 3x squared dx. So you have already part of this on top. When you multiply top and bottom by 3, you will basically find yourself integrating what? F prime of x dx all over what? F of x. You understand? So it will be something of that form. Now for the next one, for the next integral, integrating this, you see basically that the power of what is on top is less than the power of what is below, because if you multiply this and this, the power will be higher than what is top. So what you will do, you will first express this in partial fraction for you to integrate it. And remember, this is a linear factor, so you will have a on what? 1 minus 2x plus what? Look at something. Okay, what I'll advise you, I'll advise you, in order to simplify things, first write back this integral as it will be 1 on 4 integral of what? X plus 2 all over 1 minus 2x into what? X squared. You understand? Because this is a factor, there's no need of leaving it out inside. This is a real number, there's no need of leaving it inside here. Now you will express this in partial fraction. In partial fraction, this will be equal, this is a linear factor, so I will have a on 1 minus 2x plus, this is what? This is a repeated linear factor. Be very careful. This is not a quadratic factor. This is a repeated linear factor because it is x all that square. So this will be equals to b all over x plus what? C all over x squared. You understand? So be very careful, because some of you always get confused and think that this is a quadratic factor. Be very careful. This is a repeated linear factor. You should understand that. So after expressing that in partial fraction, you will see that integrating it will be very simple. You understand? So let's move to the next. For this other integral, we are going to do the same thing, because the power of the numerator, the degree of the numerator is less than the degree of the denominator. So I'll first express this in partial fraction. When I will express in partial fraction, I'll have a on x plus, this is a repeated linear factor, plus b on x squared plus what? C on x plus 4. After expressing that in partial fraction, you will just what? Integrate what you have as answer. You get what I'm saying? Okay. For this one, when you look at this, if you multiply this and this, the highest power of x here will be x squared. You understand? But if you multiply this, when you if you develop this, the highest power of x here will be x squared. The highest power of x here is x squared. So if you multiply this and this, the highest power of x below here will be what? X to the fourth. So you clearly see that the degree of x up here, the degree of x in the whole numerator is already less than the degree of x in the denominator. So what you are going to do, you express first of all this in partial fraction. When I will express this in partial fraction, this is a repeated what? Linear factor. So I will have a on what? 2 minus x plus b on what? 2 minus x squared plus, this is what? This is the first thing you are going to do here before writing this in this one in partial fraction. You see that if you calculate delta here, b square minus 4ac, how will be delta? My b is what? 0 square minus 4a 1 into c 3. So this will be equals to what? Minus 12. You see that it's less than 0. So this cannot be simplified into the product of two linear factors. So you will write it back as what? You write it back as, so to express this in partial fraction, you will have, this is b, so this will be equals to cx plus what? Plus g all over what? X squared plus 3. You get what I'm saying? So after expressing all of this, in partial fraction, after expressing all of this in partial fraction, it will be very easy for you to integrate this. I hope you get. I hope you understand what I'm saying. So let me wipe this. Let me wipe this. Okay, that was all for this. Hints I wanted to give you on the following exercises. Try to do them, and if you face difficulties in any of them, you can talk to me, text me in the group, in the WhatsApp group, and I'll give you hints on how to proceed on where you faced difficulties. So see you in the next video. In the next video, we are going to end up with this last one, some integrals of rational functions that will give rise to inverse trigonometric functions. Here there is no basic rule, there is no lecture I'll give on this. I'll just give some examples. That we are going to do for you to understand that there are some rational, if I would say rational functions that will, when integrating, in fact, you have already seen this, but when we shall dive into the examples, you will clearly, in the examples, when we shall dive into the examples, you will clearly see that without me even mentioning this, you can tackle such exercises. So see you in the next video, and I hope you do all of your exercises. See you in the next video. Take care.